So, talking about weekly time cards today, we're going to be able to calculate the total hours on a weekly time card, which sounds pretty simple. It is pretty simple. However, it's not always super easy, and there are details that you have to pay attention to. It is not a complicated thing by any means, but there are details that we need to pay attention to because if you're talking about calculating hours, the way that we talk about time is in two different units, right? We have hours and we have minutes. And hours and minutes are not the same unit of measurement. And so on a time card, it all needs to be in the same unit of measurement, which is hours. And so it'll be those conversions that will end up being those details that we need to pay attention to. Not that it's going to be challenging necessarily, it's just stuff that you have to pay close attention to. So why is it important to accurately record your hours at work? Well, I think that's kind of obvious, right? If you don't accurately record your hours, then if you are needing to record your hours in a job where you do have to do that, which Calvin sounds like you do, recording those accurately can mean the difference between getting paid what you should and definitely not getting paid what you should. So Hillary Dunlap Brown makes $9.75 an hour, helping customers at a bicycle rental shop. This book was written a while ago. That's a very low number now for hourly pay. She kept track of her hours every day this week, and now she wants to know her gross income. So by the way, it is a good idea to track your own hours as well as just trusting your company to do it. You should trust your company to do to calculate things correctly. But like I said, human error does happen. It isn't necessarily done intentionally, but it does sometimes happen. And so if you're tracking your own hours at a job where you're getting paid by the hour, that will definitely help in terms of comparing your paychecks. If you do it, you compare your paycheck and what you think you should get paid for your gross pay versus what's on your paycheck, and it ends up being the same, then things are probably good. At your job at the cinema, you're required to keep track of your hours on a weekly time card. Now, obviously, this is for most people just done on a computer these days. You log into the computer, it's good to go. In my situation, I don't have a time card. Like teachers don't have time cards. We're on salary, which we'll also talk about in this chapter as well. And this is the daily record of the time you report to work and when you leave. You compute the hours you worked each day. At the end of the week, you add the number of daily hours to find the total number of hours you work. So every single day you work that week, you add them all up. If you do not work an entire hour, here it is. Round your time to the nearest quarter of an hour. That is, I'm actually going to highlight that because that is a big part of what we're going to be doing today. In terms of the details, that is the detail that I think we need to pay closest attention to today, is rounding. If it's not an exact hour, round it to the nearest quarter of an hour. So to compute the number of hours worked in a week, just add them up, add the daily values up. So if you want to highlight that, feel free to highlight that. But we are going to be talking in terms of quarter hours as we're going through this. So it's only one piece of paper today for the notes. Short lesson, real short. So flip it on over. If you've never actually seen a time card on paper, that's often what they look like. You basically just write the time you show up, and then you write the time you leave, and then you write the time you show up again, and you write the time you leave again. We'll talk about that gap here in just a minute, why you do that twice a day. I'm sure a lot of you know. So let's see. Gail Stow is required to keep a weekly time card. Based on the time card in figure 1.1, what is the number of her A, daily hours worked on September 18th, and then B, total number of hours for the week? It actually gives us the answer here. So let's see. Looks like she's got a regular job that she shows up at between 8:15 and 8:30 every day, Monday through Friday. And she leaves between 4:30 and 5:20 every afternoon. Why is she clocking in and out twice a day? Lunch, yeah. Lunch is unpaid time. Now, if you work, I think, 4 hours in a day, you have to, you are required to, your company's required to allow you to take lunch. But it's an unpaid lunch. I think you're allowed breaks as well, right? Like 10 or 15-minute breaks during the day. No, those are paid. Those breaks are paid, but lunch is a break that oftentimes is not paid. So in most cases, it isn't. So what we're going to be doing here is we're going to be calculating the times in between the in and out, and then time in between in and out here. and then adding them together. And you can see the totals are already over here. But talking about calculating, there's a couple details we need to talk about. The first one is between 8:15 and 1:45. It says when the start time is prior to 1 o'clock and the end time is at 1 o'clock or later, add 12 to the end time. Why would you do that? Any thoughts on that? Because we're trying to figure out how many hours it is between, well, we don't have to do that for Monday necessarily. Because she's clocking out, it's not after 1 o'clock. So you could basically say 12:15 minus 8:15 to figure out the number of hours in between them. In terms of 12:15 and 8:15, what is that as a decimal in terms of when that is? Like 0.25. Why? Why is it 0.25 and not 0.15? Yeah. And so that's what I was talking about before. The details here about quarters of an hour, that's going to be important. And just in case you get kind of mixed up on that sometimes, because it is easy to do that. Because if you want to write 8:15 as a decimal in terms of hours, it's not 8.15. It's what Calvin said, it's 8.25, because 15 minutes is a fourth of an hour. So if we're talking about this over here, so let's go ahead and put this off to the side. 15 minutes equals 1/4 of an hour. 30 minutes is what fraction of an hour? Half an hour. I'm going to shorten this up a little bit. I'm going to say 1/4 hours, which equals 0.25. So you can make it a decimal. 30 minutes is a half hour, which is equal to 0.5. 45 minutes, 3/4 of an hour, which equals decimal what? What's that? 0.75. Nice. Okay. So that's what we're dealing with there. And so the idea here is to round things to the nearest quarter hour at the end of the day. So we won't necessarily always be able to do this as we're working through everything. So let's just go ahead and say, all right, we got between, we're looking at September 18th, by the way, right here. So we're looking at Thursday between from 8:15 to 1:45 p.m. And so if we were to subtract 1:45 minus 8:15, 1 hour and 45 minutes minus 8 hours and 15 minutes, that would give us a negative number, which doesn't make sense because time passed, right? We're not going back in time. And the reason for that is every 12 hours, we reset, right? We go from 12 and then it goes back to 1. And then we go to 12, goes back to 1. Unless you're in the military and you probably use military time. But that's actually what we're going to do here is convert to essentially military time, which talks about a full day as 24 hours as opposed to 2 blocks of 12. So the reason why we're adding 12 is because that'll turn that into 13:45. So if you take, so that'll be 8:45 to 8:15 to 13:45. Now, both of those actually convert nicely to decimals, but sometimes they don't convert nicely to decimals. Like if you look at Wednesday, that's 8:28 in the morning to 12:05 in the afternoon, which those are not quarter hours. And so we're not going to convert to quarter hours until the end of the problem. So I'm going to leave this as it is now. And so between those 2 hours, this would end up just being a subtraction problem of 13:45 minus 8:15. And then we can subtract this. 45 minus 15 is 30. So we're looking at 30 minutes. And then 13 minus 8 is 5. So that would be a 5 hour and 30 minute time between 8:15 and 1:45, which as a decimal would be 5.5 hours. It's 30 minutes. The 30 after that would equate to the 1/2 of an hour, which would be 0.5. So 5 hours and 30 minutes, 5.5 hours. So that's how we deal with that. Step 2 is to figure out the hours for the week. Now, it's already done for us. You worked 40 hours. So let's go ahead and do a little bit of work here. Because we already have step 2. That's done. So let's move on to, this is actually our last example of our notes. After this, you can just work on the assignment for the rest of the class. We're gonna have a lot of time to work today. We'll have a lot of time to work a lot of days. So Reggie Blanco works from 8 a.m. to 10:45 a.m. and then from 12:15 p.m. to 4:15 p.m. So I'm just going to split this. I'm going to say M for morning and then A for afternoon. Actually, I'll put the A off to the right because I have to do some subtraction here. So the morning is going to be from 10:48 to 10:45. So you just subtract the later time from the earlier time. So 10:45 minus 8. So how many hours? The 245, 2 3/4, yeah, or as a decimal, 2.75. So in the morning, 2.75. Afternoon, that would be from 12:15 to 4:15. How should we rewrite 4:15? Yeah, 16:15, because anytime you go past a 12 into the next type of value, in order to make that subtraction work and not get a negative number, you have to add 12 to the later value. So that's going to be 16:15 minus 12:15. That's going to be a 0. And so how many hours is that? Just 4. Yeah, straight up 4 hours in the afternoon. So total for the day is going to be 2.75 plus 4, which is 6.75 hours. That's how many hours will work that day. Now, the next one's going to be slightly more challenging just because we're not working in like straight up quarter-hour segments here. We're going from 7:30, which is a quarter-hour segment, to 11:55, which is not. So AM or in the morning, so M morning, we're going to go 11:55 minus 7:30. So what's 55 minus 30? 25. All right. And 11 minus 7 is 4. 25 minutes rounded to the nearest quarter of an hour would be what? 2 quarters, so a half. So it would be 4.5. So 4 hours and 25 minutes. This is where like there's a real urge to do 4.25, especially when there's a 25 there. But 25 minutes, the nearest quarter hour would be 30 minutes, which would round up to 4 hours and 30 minutes. 30 minutes, half of an hour. So AM is 4.5 hours. The afternoon, the nice thing about here is that with the afternoon, 1 to 4:50, those are both after 1 o'clock or 1 o'clock or later, which means we don't have to add 12 to this one. You only have to add 12 if you go from a 12 into a 1. And this doesn't go from a 12 into a 1, it goes from a 1 up to a 4:50. So we can just do subtraction here. So we can say 4:50, 4 hours, 4:50 in the afternoon minus 1 o'clock in the afternoon is going to be 3 hours and 50 minutes. To the nearest quarter hour, what's that going to be? That'd be rounding up 10 minutes, but rounding down 5 would be to the nearest quarter hour, right? So that would be 3 hours and 45 minutes, which would be 3.75. So that's where those little details come into play. 50 minutes is closer to 45 than it is to the next full hour. So that's where we get that. And then we're going to add the two together for the total. So that'll be 4.5 plus 3.75. So we got 5, 2, carry the 1, 8.25 hours. I do want to look at one more type of problem though before I get you your assignment. I want to look at the morning of Wednesday, September 17th. Let's go ahead and do that real quick. So Wednesday, just in step 2, we'll do Wednesday morning. So Wednesday morning, put that in step 2. So I'm going to cross off, find the total hours of the week. We'll just write Wednesday morning. Because this one is going to be a little bit different because if you look at what we're subtracting, we're going to have 12.05 minus 8, not 0.05, 12:05 p.m. minus 8:28 a.m. What issue do we run into here with subtraction? What's 5 minus 8? -3. That doesn't work. So what do we have to do? Any thoughts? This might be the most challenging type of question you get because if it's negative, negative doesn't work. What if you had something like off to the side here, let's just say 12.05 minus 8.28. Let's just say they're decimals. How would you deal with that? It's like an old elementary school skill that we actually used not last week, but the week before in that packet that we did. You remember the word for it? It's a method. What was it? That's the B. Borrowing. Yeah, borrowing method. Yeah. Heading back to like hop in the Wayback Machine, go back to elementary school real quick. The borrowing method means that we'd have to borrow from the 0, but you can't borrow from 0. So you'd have to borrow from the 2. 2 becomes a 1. 0 becomes a 10. Then we have to borrow from the 10, which becomes a 9, and the 5 becomes a 15. And we get 15 minus 8 is 7. 9 minus 2 is 7. 1 doesn't subtract 8, so we have to borrow from that one and move the 1 over here. 11 minus 8 is 3, so you get 3.77. Now, it doesn't work exactly like that over here, but it does work very similarly to that over here. There is one major thing that we have to keep in mind, and that is these are all factors of 10 when we're talking about decimals. But every time you add an hour, how many minutes are you adding? 60. You're not adding 10, you're adding 60 minutes per hour. So that's where this gets a little bit different. So yes, we have to borrow from the 0, but you can't borrow from the 0, so you have to borrow from the 2. So the 2 becomes a 1. If you add an hour to 5 minutes, because we're borrowing an hour here, right? We're changing from minutes on the right side of this colon to hours on the left side. So if we borrow an hour, what do we have to add to 5? You have to add 60 because it's 65 minutes would be an hour and 5 minutes. So it's not going to be 15 there. We're going to change that 0 to a 6. Any questions about that? I'm sure you've done math like this before. It's probably been a while since you've done stuff like this. If you have to borrow an hour in terms of minutes, you have to borrow 60 minutes. So that 5 minutes turns into 65 minutes. Now we can focus on the right side of the colon here. We still need to borrow from the 6. And when you borrow from the 6 to go to the 5, you can't just borrow a 10 from that because these are in the same units of measurement on the right side of the colon. These are all in minutes. So 15 minus 8 is 7. 5 minus 2 is 3. And then 11 minus 8 is also 3. So you get 3.37. Not 3.37. 3 hours and 37 minutes. So is 37 minutes closer to 30 minutes or 45 minutes? Is what? Yeah, it's closer to 30. It's 7 minutes away from 30. It's 8 minutes away from 45. So by 1 minute, we have to round this down to 3.5. So the morning hours worked would be 3.5 on Wednesday morning. There's kind of a lot going on in that question, or just that little tiny calculation of time, like 3 or 4 different things that had to be accomplished there. So again, the details on this are going to be kind of the big thing. And then if you look at the afternoon on Wednesday, from 12:30 to 4:30 is 4 hours, right? So that's just straight up 4 hours in the afternoon, 3.5 hours in the morning. 3.5 and 4 is 7.5, which right there on Wednesday is the total amount of work, hours worked on Wednesday. So we know that they rounded the morning to 3.5 because the afternoon is 4. Like just straight up 4. Okay, that's all I got for you. So